Now let us discuss about the way how the transaction should be rolled back, which means undoing the transaction, and how it should be rolled forward, which means you want to repeat the transaction, redoing it. Undoing takes your transaction in the backward towards the timeline, and redo takes you ahead of the timeline. So it's like progressing forward, and it's like undo is going backward. To maintain the atomicity and the transactions operation, we might do a rollback, or we might need to do redo, or we might need to do both of them. In undoing the transactions, we are going to restore all the before images to the disk. So it means like in the transaction table, we saw the BM values, right? BFIM values, right? So we want to put all this value in the disk. Okay. So in undo, what are we doing? We are putting back or restoring all the values onto the disk, which means you are going to you are going to preserve x is equal to 100, and you're going to remove x is equal to 200, because you are undoing AFIM and you are preserving BFIM. Okay, so this is called as undo. Restoring all BFIMS on the disk. Redo, restore all AFIM onto the disk. So what do we mean by redo? So it's like you are going to skip this and you're going to preserve the new values. Okay, this is called as redoing. Okay, so in order to achieve the database recovery, we might either perform undos or redos or both in a combination. Okay, these operations are, we know that they are recorded in the transaction log. They are recorded in the transaction log. From here, we do this work. Okay, now let us see the database recovery. Database, let me see if the screen is okay. Okay, so in the database recovery system cache example, let us take an example of 3 transactions, T1, T2, and T3, with couple of actions on data item A, B, C, D interchangeably. So the schedule has been constructed here. We have data item A, B, C, D. These are their initial values, and the transaction 3 starts, okay, reading the value of C. Then it reads the start transaction T3. Okay, the T3 begins, and then read item, you are going to read the item C. So whenever we read, we don't make any changes to the database. The database is changed only when there is a write action performed. So we have third one, the write action performed here, write underscore item T3 for the data item B, replacing its old 15 value with the new value 12. Then we start this transaction T2, and then the T2 tries to read the value of B. Now there is no up till now there is no write item, but now the write item is being performed by transaction 2 on the value which have been written by T3. So you see there is a write operation here, there is another write operation here, there is another write operation here. So T2 is changing T3. So if T3 is rolled back, because we did not commit it, the transaction did not commit, so what will happen? T2 is writing on the value of B, but T2 is writing a new value for item B, which have been written by transaction 3. So what happens if T3 doesn't commit? The T2 also cannot commit. So what happens here? T3 is rolled back because it did not reach its commit point. T2 is rolled back because it read the value of B, item B written by T3. So what will happen? They both will have to roll back. And then we have here another write item, T2 value trying to change the value of D. Now, if the system crashes here, how will we get the consistent value? So we will try to undo all the uncommitted values. Okay. So we go to the recovery point, which is the latest place where the database was consistent. Okay, so let's move forward and try to understand with this. Rollback. How does the rollback happen? One execution of T1, T2, and 3T are recorded in the log. This is T3, transaction 3, transaction 2, and transaction 1. T3 begins, it reads the item C, then it reads the item B, it reads the item C, then it writes the item B. And then it keeps on working, and then finally it reads the value of A. Now, whatever the value T3 is writing for B is being read by transaction 2 on the value of made by on the value of B made by T3. So your T2 is reading the item B, what have been previously written by the transaction 3. And then it keeps on writing, making changes to write operation on the item B. So if this rollbacks, this also have to roll back because T2 read the value which was written by T3 on data item B. Okay, so similarly, we have T1 working here over the timeline, and the system crashes at this point of time. So all the unrecorded transactions, uncommitted transactions, have to roll back because they are dependent on each other. Okay, so now let's move forward. Yeah, now we have something called as write ahead logging to help us with this problem. Whenever we have an in place update, you know what is an in place update? In place update is where we write to the disk So a quick recap of what in place update is. Whenever you make a change, whenever there is a change in the data item, in cache, what happens in place update? The disk version of the data item is overwritten by the cache version. So in the shadow update, we make a separate copy other than the disk. So we are having a copy of item being stored in the disk block, not in the same place, but in a separate disk. But in place, we make the changes in the original copy, right? So we are now concerned about in place updates. So let's go to WAL, writing ahead. Yeah, writing ahead logging. WAL stands for write ahead logging. When in place update, it can be immediate or it can be deferred. Okay, but and if you remember what is an immediate update, as and when there is a change in the data item by any transaction, the change or modification is written in the same time. In the deferred, we wait for some more transactions to happen, or the transaction reaches its end, and then we write the modified value into the disk. It can be done in place or in a separate copy. Now we are talking about the updations done immediately or in a deferred way, but in the in-place update. So what happens here? When an in-place update, immediate or deferred, is used, then log is necessary for recovery, right? We need to have a log for recovery because we want to know what is the new value and what is the old value. And it must be available to the recovery manager. This is achieved by writing ahead logging protocol. What does this protocol say? It says that before an item's new value, AFIM, after modification, before a data item's new value is written to the disk, okay, its older value must be written to the log, and log must be saved on a stable store. This is used for undoing. Okay, and for redoing, what we do before a transaction executes its commit operation, all its new values, AFIM, new values, must be written to a log, and log must be saved onto the stable store. So we use these two practices in write ahead logging to make sure that the log is updated, because here we are saying that log is necessary. So there must be a proper way to update the log, right? There must be a proper way to update the log. And what is the way that we are following? We are following a W ahead. W ahead means write ahead protocol. In write ahead protocol, before we undo or when we want to undo, we make sure that the older values, what are going to be written with the newer values, are first written to the log, and log is kept safely on the log disk, okay, in the stable store. For the redo, we are trying to find the new values, and we are trying to make the new values save onto the log in a stable storage, okay, and this is done before the transaction commits, okay. So this is how you preserve the values and facilitate undo and redo. Now let us see what is a database checkpointing recovery technique. In checkpointing, what we do is we maintain a time to time database flushes or write operations to the disk. And what does it do? We can randomly or follow some criteria to write the database values from the buffer to the disk to minimize the task of recovery. See, we are going to do this process at the time of recovery, right? But checkpointing is making sure that after 5 p.m., the bank transactions of Riyadh Bank or some another bank should be stored to the disk. Okay. So it is done on periodic way or in a random way, just to make sure that your consistent database state is saved onto the disk. Okay. And how does this happen? This happen in the form of database writes. Okay, from the buffer to the database disk. Okay, this will help you finally in the task of recovery, because you're doing this job in small amounts of flushes to the disk on regular basis. The following steps define a checkpoint operation. First, you have to suspend the execution of it. Okay, at the time of checkpointing, what you have to make sure, these 4 operations are followed. The first one, suspend the execution of the transaction temporarily. If any transaction is running, suspend it for some time, okay, because you want to write the database flush, right? You have to perform the database flush. What do we mean by database flush? It means that from the cache memory or from the buffer memory, you are writing the state of the data item into the memory. So when you're trying to do that, if some transaction is there, so temporarily suspend it, stop it for some time, then force write. We remember we have read about the first force write. It means that you stop the transaction and write the transaction state to the disk forcefully. Okay, so suspend the transaction from running and force the write modification buffer to the disk. Now write a checkpoint record to the log and save the log to the disk. So stop the transaction, forcefully write what items have been modified, and then mark it like a checkpoint, okay, by writing it as a checkpoint record log into your transaction log and save it to the disk. Resume, and then after you are done with these 3 steps, now you can resume with a normal transaction execution. Okay, so this is how the checkpointing is performed. Very important. Okay, during the recovery, redo or undo is required. Okay, so of course for the recovery we need to do redos and undos. Okay, that happens only after the checkpoint. So it is like you have let me give you an example. So it's like there's a database, okay, the different transactions are here, and then you mark the checkpoint here, you recorded the checkpoint. It means this all state is consistent. Now you will either redo or undo the transactions after the checkpoint, because you have already saved the consistent state before the checkpoint and you marked this as a checkpoint, right? So now the transactions that are operating after the checkpoint has to be taken care by undoing and redoing. Okay. Now let us see what do we mean by steal, no steal, and force and no force techniques. This steal and no steal, force and no force, they tell us the way how the database state or modified data items needs to be written from the buffer to the disk, or you can say from the cache to the database disk. Okay, so the way of writing the modified variables or the data items from the cache memory to the database can be done by using steal, no steal, force and no force, and the combination of these 2. Okay, that gives us 4 possible ways. Let us understand what is steal. It tells that the cache can be flushed or the contents inside the cache can be written before the transaction commits. Before the transaction commits, you can steal the data item values and you can write it into the disk. This is called as steal. No steal means cache cannot be written. Cache values cannot be written before the transaction commits. So steal is, copying the things from the cache to the disk, from the cache to the disk before the transaction commits. That is why it is called as state. But in no state, you cannot write from the cache to the disk until you perform the commit. So in no steal, you have to wait until the transaction commits. In the steal, you can write it. You can write the cache contents into the disk before the transaction commits. So you can just remember steal and no steal are copying the content from the cache to the database, one before the transaction commits, another one after transaction commits. Now let us understand what is force. Force, cache is immediately flushed. Okay, so as forcefully the word says, it is, the contents inside the cache are immediately flushed to the disk. No force, cache is deferred until the transaction commits. Okay, so quite simple. Force, you're forcing the write operation onto the disk. No force, you are deferring it until the transaction commits. So these four ways gives you the combination of the following. Steal, no force means you are flushing before the transaction commits, okay, or you are deferring the cache contents to be written until the transaction commits. So it's steal, no force, like undo and redo together. Steal force is like undo and redo together, or no steal, no force, redo and no undo. No steal force means no undo and no redo. Okay, so there are different combinations in which the handling of recovery can be performed. Now let us see what is deferred update. In the deferred update, now let us see how we recover from using the non-undo process, which is like a redo. So this recovery scheme works with deferred update using only redos. Okay, you can, if it is confusing for you to remember no undo redo, you can just remember redo as well. Okay, deferred update by using the redos. So here what we do is we update the data. Okay, we update the data by following the given below is a set of instructions. The first one is we set the transaction records, their updates in a log. Okay, so the log is very important again. Then at commit point, using write ahead logging scheme, the updates are saved onto the disk. Okay. Then after reboot from the failure, the log is used to reperform all the transactions that are affected by the failure. Undo is not required here because we don't have any after images of the values, right? So we just redo to get the new values, and we make the database work from it. This is how the recovery scheme using the deferred update works.